Hi, you guys. Welcome to this video. Thanks so much for watching this. Um, so in Math 1, there is what's called a core, and the core means what the state of Utah requires that Math 1 teachers teach their students, okay? And so for the remainder of this year in this class, we're just going to be working through some things that we haven't yet covered on the core. And this week we've been working on rational exponents and rational expressions and radical expressions. And today we are going to be talking about exponential functions. Okay, and this is something that is on the core for Math 1. This is something that you will see again in Math 2. So I would like you to please take out a piece of paper and have something to write with. Make sure you're taking notes. Pay careful attention. If you haven't taken your SAGE test yet, you may see some of the things that we're going to talk about today on your SAGE test. So this will be the last lesson for this week. So once you're done with this lesson, you will not have any class tomorrow. And I will see you next Monday. Remember, we have new lessons on Mondays, Wednesdays, and Thursdays. And so as long as you're caught up, then you don't need to come to class on Tuesdays or Fridays. So with that said, I'm going to go ahead and get started with today's lesson on exponential functions. Okay. Right here, I have a couple of examples of two exponential functions. Okay, when we look at an exponential function, this number here is the base. This number here is the exponent. Okay, notice that the base is a constant for both of these, and then the exponent is a variable. Okay, so when we're talking about an exponential function, our exponent is always going to be a variable. We also need to know that if b is any number such that b is greater than 0 and b is not equal to 1, then an exponential function is a function in the form f of x equals b to the x. So basically, our constant has to be bigger than 0, but it can't be equal to 1. Okay, and then f of x, that is the same thing as having a y. Okay, so we could rewrite this as y equals 2 to the x, or y equals 1/2 to the x. And for these exponential functions, we can see that the y is going to be dependent on whatever we plug in for the x. Okay, so we would call x our independent variable and y our dependent variable, because y is determined by whatever we plug in for the x. Okay, so with that said, we are going to go ahead and graph both of these exponential functions so that you can see what these look like as far as a graph goes. In order to graph these, we're going to use a table of values. And this is something that you learned how to do back in our graphing unit. So I'm going to go ahead and do that on the other page. We'll do this one first. We'll set up a table of values for this one, and then we'll set up a table of values for this one, and then we're going to graph them in the same coordinate plane. Okay, so if we have y is equal to 2 raised to the x power, and we want to graph this using a table of values. I'm going to go ahead and set up a table of values here. Okay, and let's just start with, we're going to do a lot of points for this, okay? So let's just start with -4, -3, -2, -1, 0, 1, 2, 3. Okay, so we're going to find out what the y is equal to when the x is equal to all these points. And actually, you know what? I'm going to find a few less here. So let's set up our table. And let's start with -3. So -3, -2, -1, 0, 1, 2, 3. Okay, so let's just start by figuring out what the y is equal to if we let the x be a -3. Okay, so y is equal to 2 to the -3. Now, we've been working with this a little bit, right? And we know that if there is a negative exponent, we would write that as y is equal to 1 over 2 to the +3. Okay, so when we have 1 over 2 to the third, we know that 2 to the third is 2 times 2 times 2. Okay, so it's not 6. 2 to the third is not 6. 2 times 2 times 2, 2 times 2 is 4. 4 times 2 is 8. So this would be y equals 1 over 8. So 1/8, that is a fraction. Oh, my pen has the hardest time writing small. So 1/8. Okay, for the next one, I'm going to go ahead and clear some more space here. We're just going to continue to create our table of values. So if we let the x be -2, so our y is going to be equal to 2 to the -2. We would need to simplify this. 2 to the -2 is going to be the same thing as 1 over 2 to the +2. 2 to the +2 is 2 times itself twice, which would be 4. Okay, so when we let the x be -2, our y is 1/4. Okay, the next one, when we let the x be -1, our y is going to be 1 over 2 to the 1. Okay, 2 to the 1 is just 2. That would be 1/2. Okay, let's go ahead and let our x be a 0. So when we let our x be a 0, anything raised to the 0 power is equal to a 1. Okay. Next one. X is 1. So if we let the x be 1, 2 to the first power is a 2. Next one, if we let the x be a 2, that would be a 4. And the last one, y equals 2 to the third. If we let the x be 3, y is going to be equal to 2 times itself 3 times, which is 8. Okay, so here is our table of values for y equals 2 to the x. We're going to go ahead and graph this in just a minute. But before we do that, let's go ahead and set up a table of values for the second function that we talked about. So y is equal to 1/2 raised to the x. Okay, so let's go ahead and set up our table of values. Let's do the same thing as we did before. Let's do -3, -2, -1, 0, 1, 2, and 3. So if I let the x be a -3 in this case, okay, the way that we need to do this is because there's a negative exponent, to make that a positive exponent, we're going to have to write this as 1 over 1/2 to the positive 3. I need a little more space. Okay, this becomes, on the top, it becomes 1 over 1. And then on the bottom, 1/2 to the 3rd power. Remember, this 3 gets distributed to both the top and the bottom of our fraction. So 1 to the 3rd is 1 times 1 times 1, which is just a 1. And 2 to the 3rd is 2 times 2 times 2, which is 8. Okay, and then when we divide fractions, we would have, we flip the second fraction over and we multiply. So this becomes 1 over 1 times by 8 over 1. Top times top is 8. 1 times 1 is 1. 8 divided by 1 is 8. Okay, so when we let the x be -3, the y is 8. Okay, let's try the next one. Let's let the x be -2. So we're going to do the same thing here. Okay, we need to take this 1/2 to the -2. We're going to rewrite this as 1 over 1/2 raised to the positive 2. We know the top of our fraction is 1 over 1. We know the bottom of our fraction, because to make 1 a fraction, we just put it over 1. Okay, so our top of our fraction is going to be 1 over 1. The bottom of our fraction, we need to distribute this exponent to both of these. So 1 raised to the 2nd power is 1. 2 raised to the 2nd power is 4. And then to divide fractions, we're going to do 1 over 1 times by 4 over 1, which is just a 4. Okay, so when the x is -2, the y is 4. Okay, let's look at another one. X is -1. So we take 1/2 raised to the -1 power. We're going to rewrite this as 1 over 1/2 raised to the positive 1 power, which gives us 1 over 1 divided by 1/2. Okay, because when we distribute the 1 to both of these, 1 to the 1st power is 1, 2 to the 1st power is 2, and then when we divide fractions, we flip the second one over and multiply. Okay, so that gives us a 2. Now, when we let the x be 0, okay, we know that anything to the 0 power is a 1. When we let the x be 1, 1/2 raised to the 1st power would just be 1/2. When we let the x be 2, 1/2 raised to the 2nd power, and we would need to distribute that exponent, so we get 1 to the 2nd power over 2 to the 2nd power. 1 to the 2nd power is just a 1, 2 to the 2nd power is 4. So when we let the x be 2, the y is 1/4. And then let's go ahead and do the last one. When we let the x be 3, 1/2 raised to the 3rd power, this 3 has to get distributed to both the top and the bottom. So 1 to the 3rd power is 1, 2 to the 3rd power is 8. This becomes 1/8. Okay, so now we have a table of values for y equals 1/2 raised to the x. We have another table of values, wherever it went, let's see, for y equals 2 to the x. So we're going to graph both of these on the same coordinate plane. Let me go ahead and make a coordinate plane here. Remember, this is my y-axis, and this is my x-axis. I'm going to bring this a little bit lower here. Okay, and we know that we were going to let we're going to go ahead and graph this one first. Okay, so we need to go from -3 to +3 on our x-axis. So here's -1, -2, -3. Here's +1, +2, +3. So this is -3, -2, -1. This is 1, 2, 3. Okay, so here's our y-axis. Here's our x-axis. And on our y-axis, it looks like we need to go up to 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. For this first one, when the x is 3, the y is 1/8. When the x is -3, the y is 1/8. Okay, so that's going to be like almost to 0, but not quite. Okay. The next one, when x is -2, the y is 1/4. Okay, so that's going to be 1/4 of the way up to 1, -2, 1/4. Okay, so this is 0, this is 1. Okay, so we've got 1/8, and then we've got 1/4. And then the next one, when the x is -1, the y is 1/2. So when the x is -1, the y is going to be 1/2. Okay, so it's in the middle of 0 and 1. Okay, let's go ahead and continue to graph here. When the x is 0, the y is 1. Okay, so there's our y-intercept right there, right? This line, or not line, this exponential function is going to cross the y-axis right there at 1. When the x is 1, the y is 2. When the x is 2, the y is 4. When the x is 3, the y is 8. Okay, so you can see that this function starts out growing slowly, and then as we increase to the right, it continues to grow faster and faster and faster and faster and faster. Okay, so it's really rapidly growing right here. So this is what a graph of an exponential function looks like. One thing I want you to notice is that this line right here, it's approaching the x-axis, but it's never going to touch it. Okay, so it just approaches it, but it's never going to touch it. And then as it moves to the right along the x-axis, we can see that it continues to go steeper and steeper and steeper and steeper here. Okay, so this would be increasing. It's increasing, isn't it? Let's go ahead and graph the other function, g of 1/2 x. If I can find that table of values. There it is. Okay, so I'm going to just kind of delete all these pages until we get close, so I don't have to keep scrolling back through. We already did this one. Okay, there we go. So if we want to graph this function right here, we're going to use this table of values that we created. If the x is -3, the y is 8. So when the x is -3, the y is 8. When the x is -2, the y is 4. 1, 2, 3, 4. When the x is -1, the y is 2. Zero, 1. Okay, so this one shares the same y-intercept. 1, 1/2. So to the right 1, up 1/2. 2, 1/4. And then 3, 1/8. Okay, so this one is decreasing, right? You can see that as we move to the right on the x-axis, this line's going to get closer and closer and closer. Not this line, this function is going to get closer and closer and closer to the x-axis, but it's never actually going to cross it, okay? That's one thing about the graph of exponential functions. This x-axis in this case would be called our asymptote, and the function is never going to cross the asymptote. It just gets really, really close to it and travels along it, but never crosses it. Okay, so for this one, you can see that it's going to decrease really, really, really quickly, and then it's going to slow down. Okay, that decrease is going to slow as it approaches the asymptote. Okay, you guys, so that is what it looks like to graph an exponential function. Okay, I'm going to have you guys watch one here from the Khan Academy. I don't know if you've ever visited the Khan Academy before, but they have really, really great lessons. And if you're ever having a question about anything in math, you can always find a video for it on the Khan Academy. And so just for future reference, when you're in other math classes, the Khan Academy is a really good resource. But we're going to watch one video that the Khan Academy put together. And it's a graph of y equals 5 to the x. And then for your quiz today, I'm going to have you do one for me. Okay, so you're going to graph an exponential function. You're going to turn that in. You need to have a table of values set up, and you need to show me the graph. Okay, so I'm going to go ahead and start the video for you, and then I'll give you the one that I want you to do, and then you can be excused for today's class.
Plot those coordinates. So let's try some negative and some positive values, and I'll try to center them around 0. So this will be my x values, this will be my y values. Let's start first with something reasonably negative, but not too negative. So let's say we start with x is equal to -2. Then y is equal to 5 to the x power, or 5 to the -2 power, which we know is the same thing as 1 over 5 to the +2 power, which is just 1/25. Now let's try another value. What happens when x is equal to -1? Then y is 5 to the -1 power, which is the same thing as 1 over 5 to the first power, or just 1/5. Now let's think about when x is equal to 0. Then y is going to be equal to 5 to the 0th power, which we know anything to the 0th power is going to be equal to 1. So this is going to be equal to 1. And then finally we have, well actually let's try a couple more points here. Let's try out, let me extend this table a little bit further. Let's try out x is equal to 1. Then y is 5 to the first power, which is just equal to 5. And let's do one last value over here. Let's see what happens when x is equal to 2. Then y is 5 squared, 5 to the second power, which is just equal to 25. And now we can plot it to see how this actually looks. So let me get some graph paper going here. My x's go as low as -2, as high as +2, and then my y's go all the way from 1/25 all the way to 25. So I have positive values over here. So let me draw it like this. So this could be my x-axis. That could be my x-axis, and then let's make this my y-axis. Draw it as neatly as I can. So let's make that my y-axis, and my x values, this could be -2, Actually make my y-axis keep going. So that's y, this is x, that's -2, that's -1, that's 0, that is 1, and that is +2. And let's plot the points. X is -2, y is 1/25. Actually, let me make the scale on the y-axis. So let's make this, so we're going to go all the way to 25. So let's say that this is 5. Actually, you have to do a little bit smaller than that too. So this is going to be 5, 10, 15, 20, and then 25 would be right where I wrote the y, give or take. So now let's plot them. -2, 1/25. -2, 1/25, 1 is going to be like there. So 1/25 is going to be really, really close to the x-axis. That's about 1/25. So that is -2, 1/25. It's not going to be on the x-axis. 1/25 is obviously greater than 0. It's going to be really, 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 really close. Now let's do this point here in orange. -1, 1/5. -1/5. 1/5 on this scale is still pretty close. It's pretty close. So that right over there is -1, 1/5. And now in blue, we have 0, 1. 0, 1 is going to be right about there. If this is 2.5, that looks about right for 1. And then we have 1, 5. 1, 5 puts us right over there. And then finally we have 2, 25. When x is 2, y is 25. 2, 25 puts us right about there. And so I think you see what happens with this function, with this graph. It starts off, the further negative in the negative x, the further in the negative direction we go, 5 to ever increasing negative powers gets us closer and closer to 0, but never quite. So we're leaving 0, getting slightly further from 0. Right at the y-axis, we have y equal 1. And then once the exponent over here, or right at x is equal to 0, we have y is equal to 1. And then once x starts increasing beyond 0, then we start seeing what the exponential is good at, which is just this very rapid increase. Some people would call it an exponential increase, which is obviously the case right over here. So then if I just keep this curve going, you see it's just going on kind of this, sometimes called a hockey stick. It just keeps on going up like this at a super fast rate, ever increasing rate. So you could keep going forever to the left and you get closer and closer and closer to 0 without quite getting to 0. So 5 to the negative billionth power is still not going to get you to 0, but it's going to get you pretty darn close to 0. But obviously if you go to 5 to the positive billionth power, you're going to get to a super huge number because this thing is just going to keep skyrocketing up like that. So let me just draw the whole curve, just make sure you see it. Over here, I'm not actually on 0, although the way I drew it, it might look like that. I'm slightly above 0. I'm increasing above that, increasing above that. As once I get into the positive x's, then I start really, really shooting up.
Okay, you guys, so you're able to see another example of an exponential function graphed through the Khan Academy lesson. So I showed you two examples. One was, I'm going to flip back to our graph that we made together. So one of them was an exponential decreasing function. Okay, so this one right here, this was our g of 1/2 raised to the x. Okay, so that was a decreasing function. So it's rapidly decreasing right here, and then that decrease continues to slow as we move to the right. The other one was exponential increase. Okay, it was y equals 2 to the x. So what I want you to do for your assignment today, for your quiz that you're going to turn into me, is I want you to do the graph of the function y equals 4 to the x power. Okay, so you guys are going to go ahead and set up a table of values. I want you to start with -3, and then you're going to do -2, -1, 0, 1, 2, and 3. Okay, so you're going to find the y values when you plug these values in for x, and then you're also going to do the graph for me. So you'll set up a coordinate plane and you'll show me, oh, sorry about that. You'll show me what this exponential function looks like. Okay, So with that said, have a really great day. Make sure you either text me a picture of this or you upload it to the Dropbox. The secret word for today, this is not very creative, is it? We're going to do Thursday. Okay, that's the secret word for today. The reason I give you that secret word is a lot of times I have kids come and ask me for help, but they haven't actually watched the video. Okay, so if I put a secret word in here, then they have to tell me what that secret word is. And then I know that they actually gave the video a try first. So with that said, you guys go ahead and have an awesome day, and I will see you on Monday.